Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a very fascinating webinar on tap today, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the webinar, you will be able to access it on demand later on. We will be sending out an email after the webinar is done that will contain a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during the presentation you have a question for our speaker, please don't hesitate. Use your GoToWebinar control panel and submit your question. We'll take probably about 15 minutes or so near the end of the presentation and go through those audience questions. All right, with that, we'll go ahead and kick off today's webinar, 3 Pillars with 0 Answers, a new observability scorecard. Our speaker today is Ben Siegelman, who is CEO and co-founder of Lightstep. Hi, Ben, how you doing?
I'm great, thank you so much. I'm excited.
Awesome. Yeah, great. So I'm gonna go ahead and turn it over to you and let you do your thing.
Okay, thank you. Yeah, thanks everyone for tuning in. I'm excited to give this presentation. Before I begin, I guess I just want to talk about the large problem that we're all faced with and the context of this presentation. In my mind, there's a migration underway in the industry at large to take monolithic applications and break them into smaller pieces, whether they're called microservices or serverless or what have you is kind of irrelevant. That goes hand in hand with a move towards more of a DevOps mindset where you have many small teams that are working at high velocity and with maximum independence. And that architectural shift is happening for really great reasons, and I'm not going to enumerate them here. Probably that's well known at this point to this audience. It has created a new problem that deserves a new word, which is observability. I think that used to be called monitoring, but maybe people felt like that didn't sound hard enough. So now we have this idea of observability, and really what this presentation is about is how to think about observability for your organization and how to reason about your own ability to observe your system. And without further ado, I think I'll get started. So let's start with a critique. So the conventional wisdom is as follows. Observing microservices is difficult. And I think anyone who's deployed them understands that just innately because it just is really hard, understanding what's going on, remediating issues, making things faster. It's slow going at the moment. There's a sense that Google and Facebook and maybe Twitter or Netflix or some set of companies like that they solved this. And I think there's some questions about that, but there's a sense that they solved this problem. And there's also some kind of oral history that has led us to believe that they solved it using metrics logging and distributed tracing. And so we should too. That's basically the logic. It's not, in my mind, completely, totally irrational or anything like that, but it's also not really a rational argument in the purest sense because we're not coming up from first principles. And it ends up feeling a bit like, to my mind, a bit dogmatic, that you have these 3 pillars of observability. That's the way they're described. There are a number of blog posts about this, and people refer to them at this point as the 3 pillars: metrics, logging, and tracing. To be clear, this presentation is not a takedown on these 3 technologies. I think they're all really important. Distributed tracing in particular is vital to Lightstep, so I'm not here to say it's not worth anything, but I'm here to say that this is not the right way to think about things. So let's quickly just make sure we know what we're talking about here collectively. Metrics, typically people think of something like this. This is a dashboard of squiggly lines, which are time series data. And people imagine that the metrics can be turned into these squiggly lines, and that when they look weird and they're anomalous, then I'm going to try this pen feature. It's so exciting. Yeah, okay, look at, let's see. Oh, maybe it's not going to work. Forget it, I won't do the pen feature. But you can see the squiggly lines going up. That means something bad is happening, and you try and investigate it. So this is the basic idea with metrics. Logging is even more of an old standard in the trade. It's this idea that you record something via a debugging statement or a print statement in your code, it ends up getting into some kind of logging platform, whether that at the simplest level is a flat file on disk, or maybe it's some kind of service like Elasticsearch, Log/Kibana, like an Elk Stack or Splunk or something like that. But you centralize all this data, and then you can search over your logs, and you can view them along different axes like host name or a particular logging statement or a time range, that sort of thing. So we all know what that looks like. And then tracing is, of the three, is the new kid on the block, but at this point I think is pretty well understood. It's the idea that, well, at least with distributed tracing, that you are able to take a request in one service that is then serviced by making calls to other services, and you can follow this request as it crosses process boundaries. And you get what looks like the Chrome Network Inspector. You get a timing diagram that spans the different microservices in your architecture for a single transaction. And this is a vital building block for sure of observability, in that you can't possibly understand transactions unless you can do this. And so people get very excited when they introduce tracing into their system, because suddenly they're able to understand what these transactions are actually doing between processes and not just within a single process. So those are the three pillars as they're described. I think that as a species, we love groups of three. These are three groups of three of things that go well together, and I think that's partly why this is caught on as a term. But each of them has a fatal flaw. This is one of my favorite cartoons of all time. Achilles telling his date that he's ready to be vulnerable. So let's just talk about what's wrong with these three things, because they all get hyped a lot, and I think they all have significant issue when it comes to microservices anyway. All right, so let's start with some vocabulary. This is a word that I think has started to proliferate into the realm of product marketing and AdWords spend. So maybe people actually care about it now, but 10 years ago, no one had ever heard this word. Even I'd say, 3 or 4 years ago, no one had heard it either. There's this idea that if you have metrics, they have dimensions or tags on them. So let's look at a metric. So this is a single metric. This is actually a real example from our own internal monitoring at Lightstep, just to make it concrete. So it doesn't matter what it is, but there's some kind of signal, something bad happened around the spike here, and you can see that reflected in the metric. And so what you want to do is use a tag on this metric to understand what exactly is correlated with this spike. So you typically do that by grouping by the tag, and then seeing which value for the tag explains that particular anomaly. So we do a group by operation, and now it looks like this. So these individual time series all add up to form this aggregate time series we started with. And indeed, it's actually a pretty clean explanation. This particular dark red line is, in fact, the component of this metric that is causing the problem. So if we look at that tag value, we have gained some important information about why this spike occurred. And I wouldn't call it a root cause analysis, but at least it's a strong hypothesis that there's a lead here. So this is all well and good. The problem is cardinality, and this is the vocabulary word that we didn't know 10 years ago, unless we were in a college level math class talking about set theory. The idea is that if a dimension has, like let's say the dimension is host name, for instance, and you have 10 hosts, that's fine. If you have 100 hosts, that's kind of iffy, but if you have 1,000 hosts or 10,000 hosts and you use it as a tag for a metric, that metric becomes 1,000 or 10,000 times as expensive in terms of dollar costs. So it's not really feasible to use high cardinality tags to do analysis in a metric system. And unfortunately, many of those high cardinality tags are precisely the things that explain the problems. Things like customer IDs or experiment IDs, container IDs, host names. Those are the sorts of things that often are correlated with a failure. And yet in a metric system, you have this, a bit of a catch-22 in that you know what you need to do to explain these issues, but if you introduce those as tags, the metric system becomes too expensive, so you can't actually go that route. So cardinality is a fatal flaw for metrics. for logging, it's actually very simple. It's just that if you think of this diagram here as representing microservices in some larger architecture, and this dotted red line is a single transaction, if you want to use logs to explain that transaction, you at the very least need to record its entry and probably exit into and out of each one of these services. And that ends up just requiring a lot of logging data. So you have to take your transaction rate. So this is just the number of transactions you're servicing at the top of your stack. You multiply that by all of the microservices that you have. And then you multiply that by the cost of the network and the storage for all of this telemetry data, this logging data. And then you multiply that by several weeks of retention, so you can actually do a before and after comparison using this data, and you end up with something that's just simply too expensive. So I think I was a speaker at a conference a year or two ago, and there's another speaker who was at a dinner that they had for presenters the night before, and he's really reputable fellow who is at an awesome, industry-leading tech company. I won't say his name because I didn't have permission to tell the story, but he was presenting about their approach to logging in a microservices environment, and I was fascinated about this topic because I care about it. And I asked him, what's the TLDR for your talk, which was like an hour-long talk. He's like, oh, it's really simple. The TLDR is in microservices don't log. And that was his basic message for his company, was to avoid logging at all costs when it comes to microservices, at least in terms of central logging for transactions, because it's simply so expensive to centralize the data that it's hard to get positive ROI from this data. And I think what I would emphasize here is this multiplying by all microservices. These other things, the transaction rate, the cost of storage, the retention, those are things that have been true about logging for decades. The difference is that as you add microservices, if you go from 0 microservices to 100, well, let's say 1 service to 100 services, what you're doing is you're basically multiplying your cost of logging by 100. But the benefit you're getting from it is the same or less, because the logging data is less interesting in a microservices environment, because there's a lot of concurrency and it's hard to make sense of it anyway. So this actually all led to the birth of distributed tracing. I was at Google in the early 2000s and was actually one of the people who built the Dapper project at Google, which is their distributed tracing system. And we pursued that project specifically because of this problem with logging. We were not able to use logging to understand what were essentially microservices at Google, and so we had to create something different, and that was distributed tracing. So this is the fatal flaw for Dapper. So Dapper was really cool in a lot of ways. We were able to address this cost problem, and we were able to record transactions every time they entered or left any microservice. We were able to centralize all that data and keep it for several weeks, and get these nice looking distributed traces out for our developers and SREs on the other side. But we did this by sampling aggressively. So the theoretical amount of data, the 100% that we started with, the very first thing we would do in a transaction was flip a coin, essentially. Well, it's not really much of a coin, because 1 out of 1,000 times we would keep the transaction, and the other 999 we would just literally drop without even inspecting them. And this allowed us to make this an always-on production tracing system, which was a requirement for Google. Even that turned out not to be enough, because the cost of centralizing even that 0.1% over the wide area network was too high. So we did another 10x sampling for the global aggregation. So when it was all said and done, we kept 1 out of every 10,000 transactions and threw all the other ones out. It turns out that for steady state latency analysis of things like Google search, which are dealing with literally millions of end user requests per second, this is sufficient. But for things like, I don't know, Google Checkout or spreadsheets, or even Gmail, where the transaction volume is lower, but the transaction complexity is still very high, Dapper was not that useful. And this is why. If you had an interesting anomalous transaction, you almost certainly were not able to examine it in Dapper, because the sampling was so aggressive. So these are the 3 pillars, and these are the 3 fatal flaws. Here's a review. Each one of them checks 2 boxes and very much does not check the other one. Logs just have a TCO problem at scale. It's nothing more complicated than that in my mind. Distributed traces, historically anyway, have done a lot of sampling, and that is a problem. And then metrics, they solve this problem of sampling and TCO by doing statistical aggregation immediately, which is why they just look like squiggly lines. But they do that aggregation along dimensions that can become very large. And when those dimensions have high cardinality, metrics become too expensive. All right, so this is the essence of my critique of the 3 pillars, that you can, and the way this ends up looking in practice, and some of you may have seen this in your organizations. If you haven't, I would love actually to hear about it in the Q&A, or if you want to critique my critique, I'd love to hear about that too. But what I've seen in talking with people in the market is that they've heard about these 3 technologies, they deploy all 3 of them, and then lo and behold, they're still not feeling like they have a handle on observability. And I think that's because we've focused on the implementation details and not on the goals of observability. And that's what this presentation is really about. So this is a common problem. If you search on Google Images for a computer, it kind of reflects this natural human tendency to think about how things look when we're describing a concept. So, you know, this is a search term. Everything that you see here are basically what a lot of them are monitors. That if you search for computer, you should get a picture of a CPU or something like that, but that's typically not what you actually get. If you ask someone what a computer looks like, they'll draw a monitor. The same thing has happened with these 3 technologies. When we talk about metrics and logs and traces, we talk about these UIs, the squiggly lines, the list of logging events, the trace diagrams. This is all a bit of a misnomer in that trace data and log data can be used to generate squiggly lines, and tracing data can also be rendered like this. And furthermore, there are other visualizations like system diagrams, detailed histograms, all sorts of other things that we can get out of trace data and logging data as well in some cases. And so these UIs aren't even really all-encompassing. Ultimately, they're just data, and they're not a feature or use case. So what I'm here to talk about for the rest of this presentation is a different way we could think about observability that doesn't tie us into a particular vendor or solution, but does allow us to think about our capabilities and then have those capabilities drive our decisions around particular technologies that we choose to adopt for our organizations. All right, so this is my new scorecard for observability. And again, I love comments and questions at the end about this. I'm happy to take feedback about it. I'm personally feel like this is a much saner way to think about the problem. All right, so another piece of vocab, there's this Google SRE book, which is somewhat popular, I think, in these circles, defines an SLI as a service level indicator. This is to be paired with an SLA, which I think is something we're more familiar with. The basic idea is that an SLI is an indicator of health that a service's consumers would care about. So it's not meant to be an indicator of its internals or its inner workings, but just its health. So for instance, if you were managing a Kafka queue, the CPU load in the Kafka queue would not be an SLI because that is an indicator of the health of the individual nodes in the cluster, but something like the end-to-end time for a message to be delivered for a particular topic would be an indicator of health because that's what the consumer actually cares about. And I could give many other examples, but I bet you get the idea. Usually a service only has a handful of SLIs that really matter. It has many, many, many implementation details, but only a handful of SLIs that actually are of interest to its consumers. So I think SLIs are what we should be really focusing on for a lot of observability, and I will frame much of this the remainder of this talk in terms of SLIs. So there are really only 2 goals in observability. One is to gradually improve an SLI, and the other is to not gradually, but as soon as possible, restore an SLI to its regular pattern. So this first one can take days, weeks, or months. This is the kind of thing where you say, you know, gosh, we have a product goal to make this particular feature 25% faster. I'm going to devote the next quarter to finding improvements and introducing caching that will help me get there. So that's improving a latency SLI over the course of months or weeks or what have you. This is more like you get woken up in the middle of the night because your SLI has spiked and is out of alignment with what your consumers expect, and so you have to figure out what to do as soon as possible. This typically takes the form of finding a bad release and rolling it back, or finding a bad data push and rolling it back, or maybe a dependency in the cloud world is broken and you need to make some kind of remediation. But if you're making code changes or getting PRs reviewed for something like this, you're probably in a bad place. This is the type of thing you want to do in a couple of minutes tops. So these are the two basic goals of observability in my mind, and they both have to do with SLIs. In terms of the activities, both of these activities service both of those goals, but there are really only two activities. One is detecting SLIs, so you want to have perfect SLI capturing. So you want to be able to measure the SLIs that are of the greatest interest to your consumers as precisely as you can. And then the other piece is to refine those, refine the search space of possible explanations for why the SLI is not what you think it should be. I'll talk more about both of these in a little bit, but detection and refinement, I think, are what we should be talking about. It turns out that there's not a perfect one-to-one mapping, but there's certainly a bit of a mapping in my mind between things like metrics and detection and things like tracing and refinement, but we'll get to that later. But these are actual activities that operators will need to participate in, and they probably more cleanly map to use cases and needs within your organization. Statistical frequency, I just want to briefly talk about this. This is data from a real production data that I grabbed from our own system. What you're looking at here is high percentile latency for a particular SLI. And the only difference between these graphs is that I've done time smoothing. So in this case, it's just, I think it's 1 second or 5 second granularity, something like that. And then I do 5x that window, 10x that window, and 25x that window to compute my percentiles. And you end up with very different looking curves. Obviously, they're smoother, but I also think it's hard to know, to interpret this graph in the bottom right. For me as an operator, it's difficult to know if this is a gradual worsening or something intermittent is happening. With this graph up here, I think it's very clear that there's an intermittent problem. And the difference between, in terms of understanding the signal, you have very different sets of hypotheses if it's an intermittent issue or if it's just a general slowing. And it's hard to understand those differences unless you have high frequency statistics. So I'm going to talk about that in a minute, but I wanted to provide a visual for it because it's abstract if we're just talking about it. So let's look at our scorecard for detection. I think what we need in terms of detection are specificity, fidelity, and freshness. So specificity means that you have totally unlimited control over cardinality. You should not be restricted by cardinality when you're trying to detect a particular symptom or a particular SLI. This is particularly interesting if you're dealing with something like tracking every release or tracking particular customers, which may be of interest at a business level. You also should think about whether or not your solution will work for your mobile and web clients. It's probably the case that if you have a consumer-facing product or a human-facing product, that at the end of the day, all of your latency work is meaningless unless it's reflected in the mobile and web experience that your end users have. And you'd like to have an observability system that could think about end user devices in the same way that you think about microservices, because they're all connected, and one is actually going to affect the other. So you need to be able to look across the stack. That also goes down the stack too, to understand dependencies that you didn't write, software that you bring in from the outside world. You need to be able to look down that stack to detect issues as well. And then for fidelity, I'm going to emphasize correct statistics. This feels sort of obvious, but when I'm not going to name names, but if I look at vendors, the way they compute things like P99 are often totally incorrect. They'll compute P99 across all of your hosts, and then they'll average the P99s and call that your global P99. that is literally meaningless statistically, and actually does cause problems. If you have a single host that has very low traffic and is very slow, it'll mess up your statistics. So you should actually look into whether your providers are doing this correctly. If they're not, there's not much point in measuring high percentile latency if it's not being measured correctly. So I would encourage people to check whether or not you're actually getting correct statistics. And then that previous slide about this, the frequency of statistics is really important and is often not something that people look at until they've deployed a particular solution. But you want to be able to see data with something close to per second resolution or 5-second resolution. If you're looking at minute granularity rollups, you're probably not going to be able to distinguish between an intermittent issue and something that's more steady state. And then finally, the data that you're consuming from your observability system should be less than 5 seconds old. If you have to wait more than that, I think in the on-call scenario, or even if you're just iterating by pushing changes and testing them, it'll slow your cycle, which adds time, but also makes it hard as a human being to context switch. You have to wait to see the new results. Like, you shouldn't have to wait for a Spark pipeline to finish to see whether or not your changes had an effect. You want to see things more or less immediately within a couple of seconds. So let's talk about refinement. So the first thing I'll show is this diagram. So as you add microservices to your architecture, your end users absolutely do not care at all. I will say that I've seen some kind of bizarre things. I think the hype around microservices, I saw a CMS, like a content management system startup, that was advertising at CMS to its audience, which are not even developers, because it uses microservices. And they're saying you should buy our CMS because we use microservices. That's not going to work. Nobody cares about your microservices in terms of end users. That's something we care about as engineers and developers, but not as end users. So you add microservices, nobody cares, but the number of failure modes in your system is going up geometrically or even exponentially, because the microservice interactions, or each one of them is a new failure mode that could take place. And getting a hold of all of those failure modes is really overwhelming. Microservices and that architecture in terms of the org chart, where you have individual teams that deploy their own service, that was designed to minimize the communication between your teams. So team A depends on team B, depends on team C. Hopefully team A and team C never need to interact. And that's mostly a good thing. It allows you to move faster. But during an emergency, or even during a non-emergency investigation into performance, the fact that you and team A don't understand team C at all is actually really problematic, because the institutional knowledge isn't there. And if your tools don't help you see into team C's behavior without, tracking them down, sending them an email, getting them to take a meeting with you, you're going to take a really long time investigating pretty straightforward things, because team A can fail because of team C, and in fact it will eventually. So you are looking at many more failure modes as you add microservices, and this is why I think refinement is really the name of the game. I think there's a lot of talk, especially from vendors, about automating root cause analysis. Lightstep may have even said things like that at times. I think that's a little bit of a stretch. I think it's much more realistic to try and speed up the refinement process. If you can have your human beings not chasing down red herring, false positives, that's a huge win, and that's about getting to the failure modes quickly. So we have to reduce the search space here. There are too many failure modes to look at them all one by one, and the basic loop that we as operators and developers go through is that you see some kind of variance in a metric, and then you try and explain that variance, usually by finding some new type of variance. So you'll see an anomaly from latency, or you'll see an anomaly from errors. You'll get some sort of lead as to why that's happening, but that lead itself will just be another metric that's not looking correct, or another trace where there's an oddity, and you have to identify why that oddity is there. And so you kind of go through the cycle until you find an explanation that you can actually act on, and then you deploy the fix. I think we probably spend, this is a false statistic, so I won't put an actual number on it, but let's just say a vast majority of our time is spent in this loop. The actual construction and deployment of fixes is minimal compared to this cycle of finding variance, finding something that's unusual, trying to explain it, and doing that over and over again. So refinement is about making this loop tighter. And that's what we ought to be thinking about, like what tools are we using in this loop and what can we do to make them more efficient. This is a screenshot of lightstep. It's not really meant to be an advertisement. It's just, I'm just trying to illustrate a point. So there's a lot of talk about P99. So that's the 99th percentile of distribution. For latency, I think it's well understood that average latency is not that useful. You should look at high percentile latency instead. I would argue that even high percentile latency is not really that good. What you're looking at here is a screenshot from lightstep where we were using very detailed histograms. And P99, so what you see here is a histogram of latency of one of our own internal systems. This is real data, so most histograms of real services look something like this, where you'll have some kind of power law distribution followed by a series of long-tail outliers. P99, you can sort of see it in gray here because I've selected this region. P99 is at this latency, so you can see this is very fast things, this is very slow things, and then the y-axis is just frequency. P99 is over here somewhere, and that's just a simple number. It's like a little over 100 milliseconds. What you see, though, if you look at the histogram, is that there's a distinct mode of behavior here, which is this power law distribution, followed by a mode here, followed by a mode there. And what you really want to do is understand which of what is different about this group of transactions from this group of transactions from this group of transactions. And you can do that if you can isolate them, which is possible in some systems and not in others. But just measuring P99, it's helpful. I'm not saying it's a bad idea. It's certainly better than measuring average, which is somewhere over here. But it's not going to help you understand the different modes of behavior in your system. And I think if we're trying to explain variance, that's vitally important. Being able to actually visually see the different modes of behavior is the first step in being able to explain them and to refine away all of this data over here, which is of no interest if you're trying to understand these outliers. All right, so identifying variance. So again, cardinality is incredibly important. In this case, it's even more important than with detection because usually you use these sorts of high cardinality tags to do refinement. In that example I gave earlier in the presentation where I showed the cardinals on the screen, we used metric tags to literally do the refinement. We were trying to figure out which tag refines this hypothesis the most effectively. So cardinality is a really big deal here. You also need really robust statistics. So that previous slide showing histograms was my attempt to illustrate the difference between using something like P99 and looking at a really detailed histogram where you can drill down into individual bumps or modes in the histogram. And then I also think it's crucial that you have some kind of historical context. It doesn't have to be a time series necessarily, but you need to be able to take what's happening right now and compare it to what was happening an hour ago, a day ago, a week ago, when things were more normal. Especially if you're looking at some other team's service during an emergency, you will not know whether or not it's normal to have these bumps over here or not. And if those are normal, it's probably a hint that this is not going to explain your current emergency. It's incredibly useful to have a system that can tell you without any effort on your part whether or not you're looking at something that's anomalous, just as a steady state feature of the solution, because you want to focus on anomalies if you are dealing with an anomaly. And then again, for explaining the variance, so here we're identifying variance, explaining variance. We need correct statistics. I'll say it again. I already gave that speech, but a lot of the times you don't actually get that. And then this idea of suppressing messengers. What this is really about is in this diagram up here, I've done a simple tree diagram of architecture where you have some kind of root service that calls a middle tier that calls something at the bottom. Of course, in real architectures, it can be a lot deeper than this, and it's not so symmetrical. But the basic idea is if you have a failure at the bottom of the stack here, that failure will probably be reflected as a failure here and a failure here. So if you are responsible for this service at the top of this diagram, you do not want to be blamed for service that's way downstream that's actually having the issue. It's not an issue, and I don't mean that in terms of finger pointing, it's more about efficiency. If someone's trying to get to the bottom of why you are out of SLI, they should really be looking as quickly as possible down to this service downstream, which is causing the problem. So what you often see in a microservice deployment is that there will be an issue at the bottom of the stack, and everybody who depends on that transitively will also be blamed. And that wastes time. It's not an issue of feelings and what it feels like to be blamed. That's also probably frustrating, but in my mind, it's more about efficiency. You want to suppress the messengers of failures in architectures and get to the one that's actually causing these others to go out of alignment. And that is not possible unless you have distributed traces built into a system pretty much from the ground up. This is one of the things that tracing can be very good at, although it runs afoul of the sampling issue I mentioned earlier. You also need to have enough tracing data that you can see the failure at the bottom of the stack. But this is a really big deal as well, especially in a microservices environment. Okay, so that's my scorecard for refinement. I'm nearly done with my kind of main talk track. I wanted to leave as much time for Q&A as possible, but I will wrap up with a couple of thoughts. So this is not meant to be like an advertisement for Lightstep, but I do want to give a hint at my perspective on these things. So as I said earlier, I was basically built the Dapper project at Google, and I have a lot of regrets about it. The biggest one are these two numbers, the 0.1%, the 0.01%. The fact that we did this sort of sampling was enormously problematic in terms of what we could actually use this tracing data for. And virtually every tracing system that's come out since Dapper has had the same type of restriction because there's a data problem here and it's hard to get around it. What we've done with Lightstep is to keep all of the data until we're regional, and then to do something different with our global centralization of tracing data, where we have pretty smart processors that are sitting out in the regional storage that take commands from the central SAS, and they do a lot of aggregation and trace assembly on demand. This allows us to always find these anomalies and also to go further than looking at individual traces to explain interactions between several traces that are contending for the same resources and things like that. This is vitally important, I think, if you're trying to explain why a system is overloaded. Lightstep is very adept at getting to the bottom of that. But the basic idea in my mind is to think of distributed tracing data as a currency that can be used to solve many of the detection and refinement problems that were described in this presentation. And this has been our approach. There are certainly other approaches out there. And another thing I would say about Lightstep is that we do not attempt to be the one ring to rule them all. We're actually fully of the opinion that a complicated service architecture probably demands a observability solution that has more than one piece in it. And our goal is to maintain portability of instrumentation and of our data so that it's possible to build a solution from Lightstep that incorporates other things, whether they be other vendors or open source technology like Grafana or Elk or what have you. And so another piece of this I probably should put in the deck is the importance of finding portable solutions, both because you're going to need to have more than one solution, more than one piece of technology in your observability stack, and also to just protect yourself against that solution becoming suboptimal years down the line. Whatever you choose today might literally be the right thing for today, but there's no saying what's going to happen in the next 3 to 5 years in this industry, and you want to maintain some optionality in terms of how you're solving your problems. So going back to my scorecard, I would summarize it this way. There's detection and refinement. These are the things that you need to optimize for. Detection is really about specificity, fidelity, and freshness. So you want to be able to measure any SLI with high precision and without waiting for it. And then the other piece of observability, refinement, is primarily about identifying variance and then explaining it. You can only do this by having unrestricted cardinality for any statistical aggregations you do. You really want to have high fidelity histograms and not just percentiles. And you need to think about how data is being retained by the solutions that you have. And if there's some really sexy view that you're excited about, if it doesn't have history built into it, it's probably not going to be that useful because you won't know whether or not a particular anomaly is normal or not. Uh, or I guess whether it's an anomaly, I should say. And then finally, you want to be able to suppress the messengers. In these big distributed systems, it's commonplace to see failures crop up across an entire area of your stack, and you need to be able to suppress the noise from the ones that are just repeating a problem that took place elsewhere. And that's pretty much my scorecard. So I hope that we have some questions. My time here is I'm in good shape. I think we have a full 20 minutes left, and I'm happy to take any questions there are.
Yeah, great. So we've gotten some questions in, but I do want to remind the audience that there's plenty of time. If you have a question for Ben, go ahead and use your GoToWebinar control panel and just submit your question there, and we'll take as many as we can during this period. The first question is, let's see, it talks about scaling. So not all companies scale like Google, Netflix, etc. So at what scale do fatal flaws become insurmountable?
Awesome question. Awesome question. So that's a good, I mean, there are different ways to think about it. I've gone through different iterations on this myself. I think there are two big variables here. One is the number, it's really ultimately the number of human beings that are working on your system. You could think about that in terms of the number of services or the number of teams, but I think the teams and the services end up both being more a function of human beings than anything about the system itself. Because microservices are typically a means to reduce the efficiency hit that you take by having more than 10 people on a project or more than a couple of projects communicating about a particular problem. So I would say that these things crop up when you cross 30 or 50 engineers. It starts to become somewhat painful. That's usually when you have too many people in the company or in the organization for any one of them to actually understand the whole thing, or even for any 5 of them to understand the whole thing. And that sort of global knowledge, once that goes away, you need to have tools that can replace it, that can give you a leg up on the global knowledge. The other angle would be transaction rate. And that one's a little bit stickier. I think it depends a lot on the type of transaction and the cost of the transaction. So, for instance, at Google, there are things like web search that were basically read-only. I mean, web searches don't modify state aside from some basic logging for, compliance purposes. And then compare that to Gmail, where almost everything you do in Gmail is a write operation at some level, even if you're just switching an unread bit or something like that. So the cost of the transactions in Gmail was much, 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 much higher, and the complexity was also much higher than it was in web search. So it depends on the application, but I think I would say you need to have independent of your headcount. If you're building up services in order to manage load, so you need the horizontal scalability of services in order to protect yourself from load, not just to reduce human communication. That's also a sign that you probably need to you're probably going to contend with the fatal flaws around data volume and things like that pretty quickly. So I think either one of those will push you in this direction.
Okay, great. The next question, let's see, to check if I've understood you correctly. Identify variance would be SLI measurements, white box measurements, which need to be complemented by the 3 pillars, and then in parentheses, black box measurement, just to make sure that that's correct. And then, but it's not one type or another. They both need to exist and complement each other. So I guess a question and a comment there.
Yeah, I think that's roughly correct. I mean, I wouldn't call tracing and metrics black box. I mean, there are types of metrics, especially that are black box. But to me, black box means you're not allowed to touch the code at all. That you're measuring things that could be observed from the outside, hence black box. So, like the canonical example of black box would be that you have some robot that's sitting there pinging your external facing front end and just verifying that it's up or that it returns results quickly enough or correctly enough. That's black box. I think most of what I've talked about here would fall under the banner of white box monitoring, but I would agree with the other piece of it. The idea is that you measure SLIs very precisely, and then you use some combination of these three technologies, logging, tracing, metrics, in order to speed up these workflows of identifying and refining explanations. The mapping from tracing, logging, and metrics to those particular use cases, I kind of intentionally didn't do that in this presentation, mainly because I don't think it's necessarily a one-to-one mapping. I think what we've seen at Lightstep in any case is that many of the most efficient ways to actually address those problems involves some kind of hybrid where it looks a bit like a metric and a bit like tracing, but it's actually both and wrapped into one. And I mean, I won't make this just about Lightstep. I think competitors have done the same thing and quite effectively. It's we need to get away from a mindset where you think of metrics as this thing that can be optimized separate from tracing and vice versa. That the best solutions to these problems probably involve a little of both. And it's going to be harder and harder to classify things as one or the other. Maybe another reason I don't like the three pillars is that they're going to be a bit muddy pretty soon.
All right, great. Just a reminder to the audience, we have plenty of time. If you have a question for Ben, just go ahead and use your GoToWebinar control panel, and we'll keep rolling along with these questions. The next one, this is a good one. Why did the three pillars concept get so much traction if it doesn't make any sense, or doesn't make much sense?
Well, that's a good question. I mean, part of it, I guess I think that it's just an attractive concept. Literally, it's an attractive concept. We like things in threes, stuff like that. The other piece of it was that I talked to someone who's an analyst. I won't say which firm they're from, but you know, an industry analyst, and their opinion about this was that the three pillars you can't lie about them, and so there's this sense that it's very objective. It's like, do you or don't you have logging, metrics, and tracing, and that people have grown weary of being promised things like instantaneous root cause analysis or you know, proactive alerting, whatever it is, some kind of magical feature. They've been promised these things, they've bought into them, they've spent, you know, hours or days or weeks integrating these things, and then they get burned. And so they were attracted to the fact that these three pillars were objectively measurable checkbox items. This same analyst agreed with me that they're unfortunately not very highly correlated with effective observability. That's why I've tried to move this particular scorecard more towards an idea, more towards ideas that are about the measurement of observability and actual outcomes, where you can't cheat by promising a feature that doesn't deliver. Like, you have to be able to explain how something fits into a particular workflow, but it's not just about checking a box, because these technologies are too complex and there are too wide a range of logging, metrics, and tracing solutions out there anyway to be able to represent them as just a single concept that you have or don't have. But I think it became popular. Excuse me. I think it became popular primarily because of its simplicity and how easily it could be evaluated.
Okay. All right. Great. Those winter colds are a bummer, aren't they?
I know. Luckily, it's a winter.
Yeah. All right. Sorry. Okay, next question. How does your team ensure the Lightstep deployment doesn't cause any performance issues?
That's a good question. So it's not really addressed in the presentation, but I love any questions about Lightstep. So we have a number of different ways that we do that. One is just through load testing, basically. So we load test all of our software and make sure that it doesn't have any performance overhead. The other thing is what we internally call a first no harm approach. So the only parts that are actually linked into the application are very, very straightforward, but they have circuit breakers built in such that if it seems like there's enough data coming through that there might be a performance overhead, we just literally start truncating and dropping things. And then, of course, we make that available, that information that we're dropping things available in our product, so you know it. That will only happen if someone is basically have made a programming error. Like if you've written a for loop that does nothing but call the Lightstep library, but that has happened, I mean, not intentionally, but it's happened accidentally, and lightstep's library correctly shuts itself off in that scenario and reports it to our end users. So the goal is just defense in depth, do load testing, have automatic shutoff valves basically. But in a functioning system that's properly instrumented, the overhead is, I don't want to say it's zero, but it's inobservable. It's in the noise of the measurement itself. So so that's how we achieve that result. And I guess the last piece of it is that we don't run a heavyweight agent. I mean, I think that should be emphasized. We run satellites. Satellites have very high overhead, but not in your application. They'll take up an entire VM. They'll take every last byte of memory you have and a lot of the CPU on that VM, but that VM is only for the satellite. I think the conventional approach for APM was to have the smarts built into the agent. It's almost impossible to do that without having overhead, which is why Lightstep has not taken that approach. We've taken advantage of the fact that networks at availability zone or per building data center level are fast enough that you can do a lot of the computation in a separate process on a separate VM. And that's how we avoid the overhead of those computations, which do have to be done somewhere.
Alrighty then. Next question. Could you give us a sense around capex and OPEX involved in deploying Lightstep?
Sure. I mean, it's going to be, and it depends. I love this question because it sounds like you want to buy something, but but more seriously, I know this sounds like a dodge, but you should talk to us. I would say that our customer retention, logo retention is 100%. So I think it's good. But I don't want to. I mean, I can't give you a number because I don't know who you are. I don't know where you work, and I think it's honest when vendors say, "Oh, it'll be this." I mean, it just depends. But for instance, if you already have tracing, it's going to be really easy. If you don't already have tracing, it's probably easier than any of your alternatives, but it will be harder than if you already have tracing. So it just depends. But we put a lot of thought and care into the way that we engage with customers, and we have internal KPIs around minimizing both of those things. So hopefully it's acceptable, but you can reach out to me separately and we can have a real conversation about it.
Yeah, okay. All right. Just a note to the audience as well. The folks at Lightstep are getting a copy of all of these questions that are being asked. So if we don't get to your question, or if your question requires a follow-up offline, just know that somebody, I'm sure, will be in touch with you following the webinar to discuss any issues or questions that you have. Okay, we are about 8 minutes to the top of the hour. We have time for a few more questions, so let's go ahead and roll along here. We understand that Lightstep is an APM, so how does Lightstep ensure its own high availability?
Well, I mean, we have an SLA that we give to our customers, and so, I mean, at some level, we're contractually obligated to do so, and we take that very seriously. It's a really complicated thing, of course, to explain how the SaaS piece works, and it's not something that we go into great detail about publicly, but we make use of. I mean, there's a few things that have been done publicly. My co-founder and CTO, Spoons, is God-given name was Daniel Spoonhauer, but everyone just calls him Spoons. He gave a talk at Google Cloud Next a couple of months ago about our use of Spanner, for instance. We've made a lot of attempt to stay away from any kind of state that is singly homed in a single region, so we can avoid outages when there's a regional issue. We, of course, have done our best to build a system that is resilient and doesn't have single points of failure. And internally, we have SLIs and SLOs for every component of our stack and try and act on alerts when there's smoke and not fire. So it's the same sorts of tactics that I think anyone would use if they're trying to maintain a high availability system. I think our actual SLA compliance has been very high throughout, even from the early days when it was just a couple of co-founders, because that's something that we just take that stuff really seriously. But it's hard to do better in my mind than just having a contract that specifies what we promise our customers, and that's what we've done.
Okay. All right, great. Next question. Is this something that only makes sense for microservices, or would it also apply to monolithic apps?
Yeah, that's a really good question. So I think there's some problems that crop up. They're more severe in a microservices environment. Like my complaint about logging, for instance, is much more relevant when you have many services. So I think that some of my critique of the three pillars is less relevant in a monolithic environment. However, I still think that the basic activities are similar. It's not identical, but it's similar. And one of my goals in thinking through this scorecard was not to have it too tightly coupled to microservices or serverless or any other particular technology. And that's, again, part of why I didn't try to say which of these things are best fulfilled by metrics or tracing or logging or what have you. I think in a monolithic environment, you have tools that are incredibly useful that just make no sense in a microservices environment. Like you can actually deploy a real honest to goodness debugger in a monolithic environment that can do wonders for explaining variants. That doesn't really make sense in a microservices environment. So things like that could be part of your story for refining hypotheses. So I think monoliths are the scorecard applies in many ways to a monolithic environment. The answers you'd get are probably quite different. And I should say it in the same sentence that microservices isn't a bit you flip either. Usually a transition to microservices is gradual, where you have a monolith that then turns into a slightly smaller monolith surrounded by a couple of services, and then that turns into a real service mesh. That transition is a gradual one, and along the way, different sorts of solutions will make sense. And I've seen customers quite rationally purchasing or building technology in order to facilitate that migration. And so another axis to think about is where your organization is headed in the next couple of years and whether the tools you have will make that transition smoother for your entire development team. So I think it should be thought about early.
All right, great. Well, we are a couple minutes out to the top of the hour, so we are going to have to end Q&A now. But I do want to thank the audience, everybody who did submit questions. There were some really great questions, and as I said earlier, if we did not get to your question, I am deeply sorry, but we'll be able to, hopefully somebody from Lightstep will be able to get in touch with you offline to discuss your question or any issues that you have. Ben Siegelman, thank you very much for giving us such a great presentation. It was really, really interesting.
Thank you very much. I really enjoyed being here.
All right, great. One more reminder for the audience that today's event has been recorded, so if you missed any or all of it, you will be able to access it online and on demand in the future. We'll be sending out an email later on today that includes a link to the webinar on demand. The webinar is also going to be on the DevOps.com website, so if you just want to listen to it again and you're over at the website, feel free to take a look at it. It will be under the webinar section, obviously, under on demand. And while you're there, check out the other webinars that we have, both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Thank you again to the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.